Today, our topic of discussion is projectile motion. What do you mean by projectile? Any object thrown vertically upwards or in the horizontal direction, we call it as a projectile. Particularly, when we are considering projectile motion, it is a motion in 2D, that is two-dimensional motion. It is motion in 2D, two-dimensional motion, that is horizontal motion, horizontal direction and vertical direction. That is, projectile motion is the motion of an object in two perpendicular directions, horizontal direction and vertical direction. Projectile motion is a motion of an object in two perpendicular directions, one horizontal with constant speed or with constant velocity and vertical direction with constant acceleration. Horizontal velocity constant and vertical direction acceleration is constant. In horizontal direction, as velocity is constant, there will be no acceleration, so horizontal acceleration is 0. Vertical motion is with constant acceleration, and that acceleration is equal to acceleration due to gravity. So again, what is projectile? It is an object thrown in the air by making some suitable angle theta with horizontal. Suppose that this is line of projection, horizontal motion, line of projection. What is line of projection? Line of projection is the line from which we project any projectile. It is the line on which projectile returns after covering its entire trajectory. So this is point of projection, O is point of projection, U is initial velocity of projection. This projectile moves from point A and achieves maximum height A and again returns to the line of projection. This distance AB is called as maximum height of the projectile. The distance between point of projection and the point at which projectile returns after traversing entire trajectory is called as a range of a projectile. What is range? Range is the horizontal distance traveled by projectile. So OC is range of the projectile, distance between point of projection and the point at which projectile returns after traversing entire trajectory. U is initial velocity of projection. Theta is angle of projection, angle made by initial velocity of projection with horizontal direction. Now, let us resolve this component U. What we will do here, we will resolve this this initial velocity of projection. We will resolve this initial velocity of projection into two directions. One is horizontal direction, that is U cos theta, we will say at UX, and component of initial velocity of projection along vertical direction, that is UY is equal to U sin theta. So in vector format we can write initial velocity of projection as U bar is equal to UX I cap plus UY j cap. So substituting values, U cos theta I cap plus U sin theta j cap. This is initial velocity of projection. This initial velocity of projection has one important character. Its horizontal component is always constant. Horizontal component Ux is equal to U cos theta. What does it mean? It means that whatever may be the point on the trajectory, at every point horizontal velocity is always constant. At point O it is U cos theta, at point D it is U cos theta, at point A it is U cos theta, at point C again it is U cos theta. So at every point horizontal component of velocity is 0, and that's why horizontal acceleration, at every point horizontal component of velocity is U cos theta and its acceleration is always 0. Now what about vertical component of initial velocity of projection? Whenever we consider projectile motion, horizontal velocity is always constant, but the component of initial velocity of projection is u sine theta, and that is not constant throughout the motion. At every point, vertical velocity changes. That is, at initial point of origin or point of projection, whenever time is 0, its vertical velocity is u sine theta. But as projectile is moving from point O to highest points, its vertical velocity will go on decreasing. At highest point, vertical velocity changes at every point. When projectile moves from point O to point A, its vertical velocity go on decreasing, and at point A, it becomes minimum and equal to 0. From point A, projectile reverses its path and its velocity again go on increasing. So vertical velocity go on changes. We have, this is parabolic path, projectile travel itself along parabolic path. This is angle of projection. This is range of a projectile, that is distance between point of projection and point where projectile returns after traversing entire trajectory. This is maximum height of the particle during its trajectory. Let this is initial velocity of projection. Let this is any general point D where velocity is v bar. Its horizontal component is again u cos theta and vertical component is u sin theta minus gt. Okay. Now at same height we have another point E say. At this point we will have same velocity v bar. That is, at same height velocity of the projectile is same, only horizontal component is having same direction, that is u cos theta, and vertical component is reversed. It is again u sin theta minus gt. At same height on trajectory, projectile has same velocity. At highest point, vertical component of velocity is 0. At highest point, vertical component of velocity is 0. That is Vy is equal to 0. That is u sin theta minus gt is equal to 0. So gt is equal to u sin theta. So t is equal to u sin theta upon g. What we are deriving here, at highest point of the trajectory, vertical component of velocity is 0. It has only horizontal component u cos theta and acceleration due to gravity g here. Okay. As vertical component is 0, with the help of v is equal to u plus at, we have u sin theta minus gt. It is given to be 0 at highest point. So this is the time taken by the projectile to move from point O to point A on the trajectory. So what we have learned here, t is equal to u sin theta upon g is the time taken by the projectile to reach up to maximum height. We call this as time of ascent. In motion under gravity, time of ascent is always equal to time of descent. So time taken by the projectile to reach up to maximum height is same as time taken by the projectile to return to the line of projection, that is from A to B. So time of ascent and time of descent is equal to, called as the time of flight. What is time of flight? Time for which projectile remains in the air, or time taken by the projectile to cover entire trajectory. And time of flight is double of this particular time of ascent, that is 2u sin theta upon g. This is time of flight. In projectile motion, formulas are very important. Let's have a look over various important formulas of the projectile motion. First one, horizontal component of initial velocity of projection u cos theta, which is constant throughout its motion. Vertical component, initial vertical component is u sin theta. This is constant throughout, but this changes at after time t. Vertical component will be u sin theta minus gt. Time of ascent is u sin theta upon g, and this is the same time of descent. From this we get total time of flight as 2u sin theta upon g. Okay. Next one is maximum height of the projectile. Height of the projectile is u square sine square theta upon 2g. Next, range of a projectile u square sine 2 theta upon g. This is formula for range of a projectile. We can modify this formula as u square 2 sine theta into cos theta upon g. So 2 taking in front side 2, u splitting u square as u and u sine theta, u cos theta upon g. So we can write u. This is initial vertical component uy. This is initial horizontal component ux. So ux into uy upon g. This is range of a projectile. So u square sine 2 theta upon g or 2 ux uy upon g. This is formula for range of a projectile. Next important formula is trajectory of the projectile. Y is equal to x tan theta minus g upon 2 u square cos square theta into x square. This is equation of trajectory of the projectile. Y is equal to x tan theta minus g upon 2 u square cos square theta into x square, or x tan theta into bracket 1 minus x upon r, where x is horizontal distance, r is horizontal maximum distance range. These are equation for trajectories. Then suppose that we have r is range and h is height and theta is angle of projection. Then the relation between height of the projectile and range of the projectile is h is equal to r by 4 tan theta. This is the relation between height and range of the projectile. This is first important concept, height and range. Next, suppose that initially particle is projected vertically upward. In this case, its height is h max, and the same particle is now projected and we get r max here. This particle is projected first of all vertically upward, where we have h max. The same particle is projected by making some angle theta with the horizontal, we get r max. In this case, h max is equal to r max upon 2. Both are different things. Here we have h and r in the same case, and here h and r are having different cases, vertically upward direction and inclined direction. Okay, suppose that we have, this is 30-degree angle and another is 60-degree angle, then we will have same range. That is, for complementary angle of projection, range is same. That is, for 30-degree angle and 60-degree angle of projection, same range. For 15-degree and 75-degree range is same. For 45-degree range is same again. For 20-degree 70-degree range is same. So for complementary angle of projection, range is same. This